In this video, I will be explaining the 2012 AP Calc BC FRQ problem number 6. And you can use a calculator for this problem, but as you will see, you won't need it that much. So the question says the function g has derivatives of all orders, and the Maclaurin series for g is the series from n equals 0 to infinity of -1 to the n times x to the 2n plus 1 over 2n plus 3. Which is equal to 1/3 x minus 1/5 x cubed plus 1/7 x to the 5th, and so on. Part A says, using the ratio test, determine the interval of convergence of the Maclaurin series for G. And as I go through all the parts, I will also explain how you can get each point and where each point comes from. So the first thing you need to know for part A is what the ratio test is. So suppose we have a series a sub n, where L is equal to the limit as n goes to infinity of the absolute value of a sub n plus 1 over a sub n. If L is less than 1, then the series is absolutely convergent, therefore it's convergent. If L is greater than 1, the series is divergent, and if L is equal to 1, the series may be divergent, conditionally convergent, or absolutely convergent. So it's basically inconclusive. So it asks us to use the ratio test to find the interval of convergence. So the first thing we're going to do is plug in n plus 1 for anywhere where there's an n and divide that by the original series. So that's what I'm doing right here. So it was x to the 2n plus 1, but if you plug in n plus 1 and distribute, you should get x to the 2n plus 3 over 2n plus 5. And then I just multiplied by the reciprocal of a sub n instead of dividing. So times 2n plus 3 over x to the 2n plus 1. And to simplify, you can just use the exponential simplifying rules that we already know. So x to the 2n plus 3 is the same as x to the 2n times x cubed, and x to the 2n plus 1 is the same as x to the 2n times x. So both the x to the 2n and x to the 2n cancel, and then you're left with an x cubed on top and an x on the bottom, which also simplify to x squared. And the 2n plus 3 and 2n plus 5 don't cancel out or simplify or anything, so we just leave it as 2n plus 3 over 2n plus 5. And we know that since the power of n is the same on both the top and bottom, we should just look at the coefficients. So it's a 2 and a 2, so that's just going to be 1. So we're just left with an x squared. So already you should have 2 points by correctly applying ratio test and then getting the correct answer, x squared. And now we have to find the interval of convergence. So we need to find where is it going to converge. And we know that it converges when L is less than 1. So we're going to set x squared, our L, less than 1. And when we take the square root of both sides, you're left with plus or minus x, and then is less than 1, which you can just write as x is in between 1 and -1. So that's where your third point comes from, by correctly simplifying it down so that you have an x now instead of an x squared. And some people might stop here thinking that they've already found the interval convergence, but that's not correct because you don't know if -1 or 1 are included in the interval convergence. So we need to analyze both those points. So at x equals -1, the series becomes -1 to the n times -1 to the 2n plus 1, which simplifies to -1 to the 3n plus 1 over 2n plus 3. So here, let's just do a quick review of the alternating series test. So if we have a series a sub n, and it's equal to -1 to the n b sub n, or -1 to the n plus 1 b sub n, where b sub n is greater than 0 for all n, then if the limit as n goes to infinity of b sub n is 0, and b sub n is a decreasing sequence, then a sub n is convergent. So we're just going to use this test to figure out if this series is convergent, and therefore we can figure out if x is equal to -1 is included in the interval of convergence. So we have to first isolate it so that we get either a -1 to the n or -1 to the n plus 1. So I just isolated it out to -1 to the 2n times -1 to the n plus 1 over 2n plus 3. And the b sub n you're left with is -1 to the 2n over 2n plus 3. And you want to check to make sure that your b sub n is greater than or equal to 0 for all n, which it is. And then do the limit as n goes to infinity of b sub n, which is just equal to 0, since -1 to the 2n is always going to be 1, since it's always going to be to an even power. And we verify that b sub n is in fact a decreasing sequence because the denominator grows at a faster rate than the numerator. And so the series is convergent at x equals -1, so that is included in the interval of convergence. And you would apply the same exact steps using alternating series test for x equals 1. So I'm not going to go through it because it's literally the same exact thing. And this is not always the case. Sometimes you'll have to use two different tests for your endpoints, but in this case, you use the same exact test, so it's literally the same thing. And you get that it does converge at x equals 1, so it is included in the interval of convergence. And this got cut off a little, but the interval of convergence is -1 to 1 included. So this is where you get your final point from. So let's just review the points really quickly. You get your first 2 points by using the ratio test and correctly identifying the limit. Your next point comes from isolating x in your interval of convergence. And then 1 point for analyzing both the endpoints. So if you didn't analyze one of them correctly, you wouldn't get that point. And then 1 point for the correct answer, of course. Part B says the Maclaurin series for G, evaluated at x equals 1/2, is an alternating series whose terms decrease in absolute value to 0. The approximation for G of 1/2 using the first two non-zero terms of this series is 17 over 120. Show that this approximation differs from G of 1/2 by less than 1 over 200. So in the problem, it gives you that the terms decrease in absolute value to 0. So basically, it's telling you that the series is convergent. And it also tells you that it's an alternating series. So we know that we can use the alternating series estimation theorem. So r sub n of x is less than or equal to a sub n plus 1, as we know, where r sub n is equal to 2 since it's the first two terms, and it's centered around 1/2. So x is 1/2. And we know that that's going to be less than the third term of the series. Now, where are we getting this third term from? We're getting it from the original problem, where it lists out for us the terms. And the third term is x to the 5th over 7. So we just plug in our x, which is 1/2, into this, and we get 1 over 224. So you would get 2 points from this problem. The first point you would get from correctly inputting the 1/2 into the correct third term of the series. And then, of course, for evaluating it correctly and getting 1 over 224, you'd get your second point. So that's a pretty easy 2 points to get. Part C says write the first 3 non-zero terms and the general term of a Maclaurin series for G prime of x. So the Maclaurin series for G we know is -1 to the n times x to the 2n plus 1 over 2n plus 3. And the Maclaurin series for G prime, well, we can just derive this series and we would get the general term for the Maclaurin series for G prime. So we bring the 2n plus 1 to the front and we subtract 1 from the exponent, just like we always derive. So when we do that, we get -1 to the n times 2n plus 1 over 2n plus 3 times x to the 2n. So this is the general term. And it also asks us to list the first 3 non-zero terms. So this does not necessarily mean the first 3 terms because the first term could be 0. So we're just going to check each one. So at n equals 0, your first term is going to be 1 over 3. At n equals 1, you're going to get -3 over 5 times x squared. And at n equals 2, you're going to get 5/7 x to the 4th. So none of these are 0, so we're good. We have our first 3 non-zero terms. So again, this was just done by plugging in your n values into the series. So it's super easy. So you basically are done with the problem now. You have your first 3 non-zero terms and your general term. Now all you have to do is list it out. So 1/3 minus 3/5 x squared plus 5/7 x to the 4th plus, and then you want to list out your general term after doing a few dots. And then -1 to the n times 2n plus 1 over 2n plus 3 times x to the 2n. And you would get 1 point for correctly listing the first 3 non-zero terms, and 1 point for correctly listing your general term. So again, this is a pretty easy problem to get your 2 points on, just like the last part was. And definitely the hardest part of this FRQ was part A with 5 points, where you could make some silly mistakes and lose out on some easy points. Thanks for watching. Hope this video helped.